Good afternoon, everybody. My name is David Yokin. I'm senior lecturer at the Turku University of Applied Sciences Arts Academy. And I'm very pleased today that we have a wonderful guest from the Finnish Meteorological Institution, Maria Hieta. I think I pronounced that correctly. We're a small live group here, a trio who's on this webinar, but I know that our members will be viewing this on the archived website. I just quickly want to mention a little bit about reflection on our network, the Nordic Council of Ministers funded Nord Plus program, the Creative Arts Pedagogy and the Environment. We have a very large partnership and geographic sweep from Greenland all the way down to Lithuania. We are including both Nordic and Baltic countries. We have partners who are focused on the performing arts, on music, visual arts, environmental and biological sciences, and we're also, of course, in the theme of pedagogy. We're all dedicated teachers in these fields, along with being researchers. So I'm going to say good afternoon, possibly a late morning for some of our partners, a mid-morning or an early morning, maybe not on this live webinar, but at some point when you are watching, because we also have non-members of the network who also follow the webinars. They're in Spain, they're in the United States, elsewhere. I just also want to mention one other aspect of my role and duty. I'm the chair of the board of directors of the Fulbright Finland Foundation, and with regards to environmental issues, we're very active in something called the Fulbright Arctic Initiative. This is a US State Department sponsored program that brings together the 8 members of the Arctic Council from Russia, Finland, Sweden, Norway, including Greenland and the Faroe Islands, Iceland, Canada, and the US. And currently we have researchers doing a lot of collaborative work and multi-professional teamwork, different interdisciplinary approaches to solving or at least addressing the climate crisis that is existing. And we're very proud. This is the 3rd cohort gathering of this group of researchers who do cross their disciplines and work on issues of healthcare, of Arctic security, etc. But to our main focus today, and Maria Hieta, know that you have all hopefully read her biography that was included in the information, but I'm going to turn over things to Maria, and she's going to introduce herself. And once again, we thank you very much for your time this afternoon. Maria.
Thank you. Let me first try sharing my screen, because if that doesn't work, then we have technical issues. Okay, let me just quickly. Do you now see my presentation? I cannot hear you if you said something.
Yes.
Excellent, excellent. So yeah, so hi everyone from my side also. My name is Maria Hieta. I work as a researcher/engineer at Finnish Meteorological Institute. I have studied both astronomy and space technology, and those are nicely combined in my work at the Finnish Meteorological Institute Planetary Research and Space Technology Group. So today I will tell you about Mars and what do we do on Mars and why we are there. So first, let's start with a very brief history of space research in Finnish Meteorological Institute, FMI. It all began in 1838 with the foundation of Helsinki Magnetic and Meteorological Observatory. In 1844, we can count a space research as started because magnetic measurements were taken regularly since then. So Earth's magnetic field is part of a space environment around us. 1957, Aurora camera network started regular operation in the north. And 1985, manufacturing of the first Finnish space hardware begins. So hardware now includes like measurement instruments, but also computers and different kinds of parts of spacecrafts. These were for Soviet Union's Phobos 1 and 2 missions. In the picture here, we have one of first instruments, but not the very first one. This is from 19th. Here we have Pekka Riihelä from FMI with Aspera instrument. Pekka recently retired, so he worked a long career with space instrumentation. 1988, the first Finnish space hardware had its first flight. Well, that wasn't very successful. These Phobos missions unfortunately didn't reach their destination, but that's what happens with space research. And finally, 2021, I have counted that we have participated in more than 50 space missions. So usually there is a small instrument or a part of instrument, maybe software, quality management or project management or any kind of contribution to these missions. So we have really been involved in many different types of missions. So what is space research in FMI? It actually covers a lot of different kinds of research. One is space weather research. Space weather is what is around our own Earth. It has a magnetic field, it has ionosphere, interaction with the sun mostly, and that is studied with satellites and ground-based measurements. Auroras is one example of space weather phenomena that is researched. We also have Arctic Space Center in Sodankylä, which is really cool place used for receiving satellite data, for example. We also are part of Pegasus Consortium, which is pan-European consortium for aviation space weather user services. So we provide also these space weather services and space weather forecasts, because those might affect aviation, for example. Then we built our own space instruments and different types of hardware. We have our own space lab, the downstairs of the Meteorological Institute. Then we study planetary plasma environments, usually with satellites, around different solar system objects, the Sun, the Earth, Mars, for example, also. Then we study atmospheres of solar system bodies. The solar system bodies covers also moons like Titan, which is a huge moon of Saturn, and it has actually an atmosphere. The last picture here, the Swan Instrument, is a particle instrument that measures Lyman alpha radiation, and it's part of SOHO, which is the Solar Observatory, which has been working since 1995 and is still operational. So that is one example of really long working instruments that we have delivered. So we have many research groups and different kinds of space research. And now let's go to Mars. This is an actual image from this red planet. So Mars is far away from the Sun. If we start from the closest to the Sun, we have Mercury, Venus, Earth, and then Mars. So it's a bit farther from the Sun. That means that 1 year on Mars is actually 2 years on Earth. So a year is very long. Mars is a smaller planet compared to Earth, but it is composed of mainly similar things like rocks, and it has an iron core. So these are like rocky planets, Mars and Earth both. Mars has 2 moons, Phobos and Deimos. Mars is a very cold planet. The temperature is averaging -50 degrees Celsius, but it can be at the poles as low as -140 degrees Celsius. But during the summer, close to the equator, it can be even plus 20. Here you can see the structure of Earth and Mars. They have both some kind of a core, mantle, and crust. Mars is smaller and the dynamics are a bit different, but basically the building blocks are quite similar. The atmosphere of Mars is very thin. It's only 1% of what we have on Earth, and it's not air, it is carbon dioxide, so it's poisonous for us humans to breathe on Mars. The gravity is smaller than Earth, so it would be easier to fly and jump on Mars. And that also causes everything to weight less on Mars. This is how the planet actually looks from the orbit. This is a real image taken by a Viking mission by NASA. What do we see here? We see that the planet is quite reddish. That is because of a rusty dust. There's a lot of iron that is rusted, so everything is covered with this rust color. Then we see polar ice caps. Here we see the northern polar ice cap. It is not only water ice, it's also mainly carbon dioxide ice. It is so cold that the carbon dioxide is freezing. Then we see these circular forms on the left. Those are ancient volcanoes. We have Tharsis volcanic region, and the largest of these volcanoes is Olympus Mons. This is a very like lava flow area. Then we see this huge canyon system across the planet that is called Valles Marineris. That is the largest systems on solar system. Now let's take a bit closer look on what features we can find on Mars. This I already mentioned, volcanoes. The picture on top is Olympus Mons, which is the highest mountain of all planets. It is 21.9 kilometers high, when Mount Everest is only 8.8 kilometers. So it is really huge. It would cover half of Finland. It is also very large, not only high, but also like really wide. So Mars has been volcanically active in the past. We know that for sure. Also Earth was at some point. But the last eruption was at least 10 million years ago. So now there is no volcanic activity anymore. But that has left its marks on the surface. We can see these old volcanoes because there's not so much erosion as we have on Earth. We have water, we have rain. On Mars, we only have wind and dust. Then we see canyons. This Valles Marineris is on this map over the whole US. So you can see how huge this channel system is. There's a tiny little speck on the map which shows the Grand Canyon. So the Grand Canyon compared to this Valles Marineris is really tiny. This Valles Marineris system is really wide, deep, and long, and it's probably a crack in the whole Martian crust. It's not made by water, like Grand Canyon, for example, but it's a huge crack in the surface of the planet. But it also has been widened by erosion. And there is clear channels that have been formed by water or carbon dioxide. That is pictured here in the middle. So we are quite sure that there has been liquid water at some point. Mars is a dusty planet, and there's local dust storms, and there's planet-wide dust storms. It doesn't happen every year, but quite often there's a huge dust storm that covers the whole planet, and it can last for many weeks. Because of the low gravity, the dust is easily lifted and can stay in the atmosphere for a long time. And for example, because there's no rain, the dust won't rain down with the water, it just stays in the atmosphere. There was a large dust storm in 2018, and that unfortunately led to Opportunity Rover to stop communicating back to Earth. It was darkened for so long that it didn't have any power left in the solar panels. This image here is from 2001, so this happens regularly. Here's a picture of inside Mars lander after landing on the left, and then about 110 days later, it is totally covered with dust. So this is something that we have to always take into account on Mars. And if we use solar panels, like this circular shape is actually a solar panel powering this inside lander. If it's covered with dust, it won't power and provide power anymore. So this is limiting factor when designing systems on Mars. Some rovers, like the NASA's Curiosity and Perseverance, do not mind dust so much because they are not powered with solar panels, but RTGs, which is a radioisotope thermal generator. It means it uses radioactive decay to make power, so it doesn't mind the dust so much. Then there's dust devils. Here in the picture, you can see a dust devil which is moving across the surface. This is something that we see quite a lot on the Martian surface. So even when it's only a 1% of the atmosphere that we have on Earth, there is still these kind of dust storms, dust devils, clouds, that kind of atmospheric phenomena. So it is not empty, definitely. This data on the left is from our pressure instrument on board Curiosity. Perseverance is still also measuring these dust devils and dust vortices, but the mission is still so new that we haven't published these results yet. Then water on Mars. For a long time, humans didn't really know if there is water. At some point in the history, we thought that there really is channels and probably Martians living on Mars. But after we sent first probes towards Mars, it started to look really dead and dry planet. But as we dug in deeper to Mars research and sent landers, now we know that there is actually quite a lot of water on Mars. But that is frozen. It is frozen on the poles and below the surface. There is also some in the atmosphere, but mostly it's on ground. There's actually so much water that if all water was melted, it would cover the planet to some depth. One reading I found is 35 meters, but this is definitely, it is a bit vague, like how much exactly there is water, but there is. But current conditions make liquid water impossible to appear on the surface. It would evaporate very soon because of the low pressure. But it's possible that there might be outbursts from below the surface that could cause these channels and phenomena that we can see in these pictures, because it definitely looks like there has been liquid water running. Also, CO2 could be reason for this. And then the picture on the left is a crater, which is filled with ice. It can be water ice or carbon dioxide ice. So in some places, there really is a lot of water ice. Mars hasn't always been like it is nowadays. Billions of years ago, we know that Mars was a wet planet. We can see it from for example, from the minerals on the surface of Mars. We know that they have formed when touching water. So there has been lakes or maybe even seas on the surface of Mars. There's different estimations of how much water there was and for how long period, that we don't know either for sure. And the water was probably saline, so it was salty. So that means that Mars must have been also warmer in the past, so that it would make possible these lakes or seas. But this is something that is very much under research still. Then there is some invaders on Martian surface. There are robotic invaders from Earth covering the Martian surface. In this map, there's locations of some Mars landers that we have sent. I think these are only the ones that have been working, because there's also many missions that have failed to land because it's difficult to land on another planet. Let's take a closer look now to the instruments that we use to explore Mars. Us at FMI have manufactured pressure and relative humidity instruments that we measure the atmospheric pressure and the atmospheric humidity. We have made these instruments for many missions already, starting from Mars 96 that was launched in 1996. Well, that didn't go very well. The Mars 96 didn't survive the launch very well. It actually crashed back to Earth. Then there was a Mars Polar Lander, which had our pressure instrument, but that was lost during the landing. Then Beagle 2 was European Mars lander. It did land, but it never called home, so something went wrong. Finally, NASA's Phoenix lander 2007 managed to land and explore the Martian polar region. It was really interesting time. Phoenix had this kind of scoop, and it scooped the surface and it found ice below the surface. And then we saw the ice evaporate, and it was water ice. So there is water ice not very deep below the surface. Then we have a pair of instruments, both pressure and humidity, onboard Curiosity, which landed 2011. Then we had sensors on European ExoMars 16 in Schiaparelli lander, but the landing failed. Perseverance 2020 is the latest successful landing, NASA's huge rover. And we have instruments in upcoming ExoMars 2022 mission. The first picture on the right is Mars 96 Penetrator. That was actually a huge lander that was supposed to impact the surface. It weighed almost 100 kilograms. Then the Beagle 2 is here on the lower right. It had this kind of petals that had solar panels, and it opened these petals after landing. But something happened, and the last petal seemed not to have been opened, and there was the antenna below that last petal. And then the picture on the middle is ExoMars. It has this surface platform, and the rover is first sitting on this platform. The platform is mostly made by Russian Lavochkin, and then the rover is European. But this is a combined mission of Roscosmos and ESA. Our instruments are in this landing platform, which stays in place. Then let's see more closely NASA's 2020 rover Perseverance. This is a sister of Curiosity. They are very similar. Perseverance landed in February 21, so this year. The landing was a bit not as they used to be because of the corona situation. Myself also, I was supposed to be at JPL monitoring the landing, but instead I was home in the dark watching the landing alone because it was late in the evening.
JPL is the Jet Propulsion Lab, and that's in Los Angeles?
Yes, that's in Pasadena, yeah, in California.
Yep, Pasadena, yep.
Yeah, sorry, it's not obvious to everyone what is JPL. Yeah, but it was the same for the JPL engineers and NASA engineers and scientists also. Everyone was home. Only those very vital people were monitoring this together. But mostly the staff was home. So this Perseverance is a successor to Curiosity. They even look very similar, but Perseverance has upgraded instruments and it has new sampling system. So Perseverance is actually a robotic geologist whose goal is to study the rocks and landscape and to search signs of ancient life. So ancient is a key here. It is not looking for microbes or current life. It's looking for ancient life. And the area where the Perseverance has landed is an old river delta. So there has been a river leading to a lake. And that is a nice area to try to find these signs of ancient life or signs of habitable environment at that time also. And Perseverance is equipped with sampling system, so it can drill a sample and then analyze and store the sample and finally leave a stash of samples on the surface of Mars for later mission, Mars sample return mission, to come and pick those samples up and bring back to Earth. So that is one of Perseverance's main missions, is to find these samples to be taken back to Earth. Yeah, that is really exciting. And that is something we have never done before. There was also a small helicopter traveling together with Perseverance under its belly. Unfortunately, it's not here in the picture. It is a small helicopter that has been testing flying on Mars. And so it happens you can fly on Mars, even with this really thin atmosphere. It is possible. So in this picture, there's a list of instruments on Perseverance. There's SuperCam, MastCam, different type of cameras. There's RimFax, there's a radar. MOXIE is really cool experiment to create oxygen from the CO2. Oxygen would be really important to have if we ever send humans on Mars, for example. Then Pixel is on the arm. It's a spectrometer to study the rocks. And finally, MEDA, the weather station. So MEDA comes from words Mars Environmental Dynamics Analyzer. So it is basically a weather station on wheels. Having wheels for a weather station has like ups and downs. It is also perfectly okay for weather stations to stay on one place, but it's interesting to see how the conditions change when you travel. So this Martian weather station actually includes very similar instruments that you would expect to have on a weather station on Earth also. It measures air temperature, pressure, radiation, dust. It measures humidity and wind. It also measures a couple of other things. SkyCam measures density of the atmosphere, and thermal infrared sensor measures ground temperature and temperature at different heights. From these instruments, we have provided pressure and humidity sensors. You can see me in this picture holding these pressure and humidity sensors. So these are really tiny. This is in our own clean room. So we develop, we test, we calibrate these instruments at FMI. These are based on Vaisala sensor technology, which we transfer from weather stations on Earth to Mars. So this technology is used widely on Earth, and together with Vaisala, we have transferred that to Mars. We have to do quite a lot of changes to these sensors to make them survive the Martian environment. They have to survive the launch. There's a lot of vibrations, then a landing shock. They have to survive huge temperature variations. The humidity sensor you can see on the head of Perseverance. It is sticking from its neck. So it is it is attached to the environment, which on the night can be minus 80 degrees, on the day it can be minus 10 or minus 20 degrees. So the variation is huge, and the electronics need to withstand that all. Here's a couple of pictures after landing. It was really cool to see my instruments that I have hold in my hands now on Mars. On the right here, I have circled the humidity sensor. That it is really small, but you can just see it behind Perseverance's head. Then there's another picture of humidity sensor on the left. Above is a wind sensor, also part of this weather station. And then the pressure sensor is inside the Perseverance's belly, so it's difficult to see. But there is a small inlet on the top deck, which I have circled in the middle picture. So now we are on Mars, and we have been working. Now there's a picture of the helicopter Ingenuity. Perseverance took this selfie with the copter a while ago. Perseverance have been drilling. The first sample was really mysterious because it disappeared. Perseverance drilled a rock, which we can see on the left side, the top picture, but it seemed the rock was too weak and crumbled, and in the end there was no sample in the sample tube. That was really mysterious and exciting. Then we tried again and managed to take our first sample. It's this bottom left picture. The golden looking ring is the sample tube, and we can see that there is a rock sample inside the tube. Then the top picture is a map, which is available in NASA web pages for everyone, where you can see the current location of Perseverance. So it has been traveling quite a lot now. It has been looking for different regions and interesting rocks to take samples and pictures of. But why on earth are we studying Mars? And now, I mean, especially us at Finnish Meteorological Institute, why are we interested in Mars? Well, Mars is it's not that different from Earth in some ways. The Mars is rotating around its axis, like Earth also, and they have the same inclination, which means that Mars has seasons like Earth. It has winter, it has summer, and spring and autumn. And these polar ice caps, they are melting during summer, and then they are freezing again during winter. And that causes the atmospheric dynamics to be a bit similar than on Earth. And Mars does not have, for example, lakes, seas, forests, any kind of trees or plants. So it is kind of a simplified version of Earth that we can concentrate on the atmospheric movement and not so much about the plants and the seas and that kind of things. And what we do is we compare these planets to our own Earth and try to learn something new. And not also only Mars, but also Venus. Venus is a sister planet of Earth. Here in the picture, Earth is in the middle. On the right side, there's Mars, and left side, there's a Venus. So you can see that Venus actually is very similar in size compared to Earth. But how are these rocky planets evolved to be so different today? What happened, for example, to water on Mars? And why is there an extreme greenhouse effect going on Venus? The surface temperature is almost 500 degrees Celsius. How did that happen? And can we learn something about Earth by studying these other planets? Quite surely we can. But in order to do that, we need something a bit more. Now we have currently Curiosity, we have Perseverance, and we have InSight working in Mars. And they provide information about the atmosphere and weather in 3 different locations, but they are all quite close to the equator. And it's quite difficult to predict the weather for the whole planet based on only 3 stations. Well, if the ExoMars 2022 manages to land also, we might have a 4th station, but it's still not enough. Like on Earth, we would also need a weather network on Mars. Those could be just small stations scattered around the planet, but to cover the whole planet. So we could easily create, like take measurements at the same time and develop our weather models for Mars also. That's what research groups in Helsinki University and FMI are doing. They take weather models from Earth and try to transfer them to Mars and see how they work. So that is really interesting. But we need more data from the surface. And that is actually something we have been doing for the past about 20 years. And we have also just finishing a new project about this kind of networks. On the right side, you can see MetNet Penetrator. This is a miniature penetrator that is designed to be released from an orbiter around Mars. It has this inflatable braking units that can be packed in really small size, and then it's just dropped and it impacts the surface, then starts to operate as a station. You can see the landing sheen here in the middle. After landing, it just raises its mast and antennas and starts sending data. It doesn't move, it doesn't have to move. So very recently, we have been working with ESA in an ESA-funded project called MiniPins, where we have further developed this kind of miniature Mars landers that could be used as a network. This project is called MiniPins, and it also includes a small station for Moon, but now we are concentrating on Mars. But this is our vision for the future, what we need to further develop our weather models and understanding of the Martian climate and the weather. Again, in order to learn something more also about Earth. One thing that we already have learned is about dust, because dust is very important on Mars. A research group in Helsinki University have already made some correction to models used on Earth that we have directly gained from Mars measurements. So this is something that is really, really cool. And I think I have used almost my time, but this is the last slide. This is me with a Curiosity's model. So you can see that this actually is quite big. It's taller than me. This is at the Jet Propulsion Laboratory. We were able to participate in the final tests of the rover because we did also calibration for our own instruments. It was so cool to see the people at NASA JPL working with this project. It's really a huge family. Engineers and scientists. Of course, now we get data from Mars every day, and we know that our all instruments work, and we will soon start publishing our first results from the Perseverance mission. So that is really exciting. So that's it. Here you can see my email if you want to send any questions. We have a homepage for space activities and FMI, and we have a FMI Space Twitter account, and I have also my personal professional account if you are on Twitter. So I can take any questions now if you have. Yes.
I'm trying to switch over to our standard. Would it be, yes. Well, first of all, thank you so much, Maria. That was so illuminating. I have many questions, and I don't want to take the floor from everybody else, but I can start a little bit. I'm going to go back a little bit to the beginning. That was fascinating to hear the history of FM space research in Finland, and that it was so prominent or active prior to Finnish independence. Was it exclusively? This is more of a historical question about the information. In 1838, was it exclusively Finnish in its context, or how was that?
Yeah, that is really a very historical question, and I'm not the correct person to answer that.
Okay. Oh, okay. I can look that up. I was curious, would the saline water, could that support some kind of simple life form, or is the amount of salt would just not be able to sustain anything in a microorganism level?
Well, that is one of the questions that are under research now. And even scientists are split in do we believe that there has been life or not? Some say that it's very likely that there has been some form of life on Mars also, but some say that probably not. But if there would be life today on Mars, it probably would be hiding under the surface, where also this is water. There has been some studies about also liquid water below the surface, but I'm not sure if those have been confirmed yet. So that kind of signs of microbial life is something that Perseverance also is looking for.
Right. Is Minipins, is that exclusively the Finnish Meteorological Institute's focus, or are you in collaboration with others?
Good question. We are leading the study, but we have collaboration with many institutes, mainly Spanish institutes, INTA, CAB, IMDEA, IMSE. There's many partners in Spain. We have also worked with the Spanish partners already in the MedNet project, in which our main partner was Lavoskin in Moscow.
I have two more comments, and then I will turn it over to my colleagues here. The first one, let's see, where was it? I just had it here. But maybe I just go to my last kind of observation. It seems that there is absolutely a level of emotion in the context of the science of success and failure. I mean, I could feel the joy from the opportunities that you've had in these successful missions, and that's so revealing, because those of us outside of this focus think that scientists are just dealing with the numbers, but there is a whole level of emotion,
Yes.
and that's quite fantastic.
Yes, especially the landing that is so nerve-wracking. You just wait and wait if your work for the past 10 years will land or not.
Do you know about the OMG project from JPL, the Oceans Melting Greenland project?
I don't think I know that.
Okay. Anyway, I have a billion more, but please, my colleagues, I'm sure there's some others who would like to ask some questions.
Yeah, I would like to ask, thank you, Maria, for a really very interesting presentation, very talk. I just curious if you told that you get data every day, but those data coming at the same day, like it taken, or it is some lag, some days, I don't know how to say.
There is some lag. That was a really good question. Thank you. So the rover collects the data, and then it will have to wait for a satellite to fly past. So the rover cannot communicate directly to Earth. So there is many orbiters currently that can be used for this data transfer. So every day there's probably at least one overflight. So the rover sends the data to the satellite, and the satellite relays to the Earth. So there is some delay.
Yeah, it's very interesting. Yeah, thank you.
That was my questions. Thank you for Renata, who's our colleague in the Cape Network. What is the time transmission from the moment that, do you have any sense of when the information is going to the satellite and how long it takes to get to your receivers?
Yeah, it depends on the distance of the planet, because it changes. The distance between planet Earth and Mars changes, and it can be, for example, 20 minutes. And especially during landing, it was really exciting because the information about the landing reaches us a long time after it has already happened on Mars. So that is really, and that's the reason also why the landing cannot be controlled from Earth. There cannot be anyone controlling it with the joystick, for example, because of the huge time delay.
I was watching that landing, I think live on CNN or something, and had I had a bottle of champagne, I probably would have opened that also with everybody else. Just going through my notes. I don't know if anybody else has other questions.
I don't know. Of course, there's also could be many questions, but I just, okay, some scientists you told that they predict that it could be life there was before, but do they found any, I don't know, some evidence, some, I don't know, spores or something? I cannot imagine what, or just because of water, they think that it was life.
The old belief that there was life on Mars came from telescope observations when someone thought that they see channels that has been clearly like man-made on Mars, like in these direct lines that look like cannot be formed by nature, but it was just an optical illusion. There really is not like this kind of a channel system. But that really caused a lot of sci-fi books and movies and inspiration. But there has not really been any evidence of Martian life so far. We have been looking for really hard, but the current belief is that there has been like conditions in the past that could have made life possible.
Okay.
It also must be really on such an interesting level for you, having these, that it's not a singular entity who is building and creating these programs, but it is such a kind of worldwide global contribution.
Yes, yes, truly. And it's an honor to be a part of this kind of mission. How you actually get into this kind of mission is the process is usually so that some space agencies, our NASA, for example, comes up with a mission plan that we are going to send a big rover on Mars. And they have a plan about what kind of science they want the rover or lander or satellite to do. And then they open a call to everyone to propose instruments and systems to the mission. And that is what we have done. And we have, for example, MEDA was one that proposed to have this weather station on Perseverance. And there was some competition, but MEDA was then selected. So we have an honor to be in this mission.
And that was also fascinating that you were speaking about, I believe it was Perseverance, is those core samples will be left to be picked up, I think is what the term you used. And that's that's also a fascinating image of something being left and then the ability to find it with the incoming instrument.
Yes, that is going to be really exciting when these plans go forward. There is, of course, plans of this Mars sample return mission. It's going to be ESA and NASA combined, and it might be even more than one landing. We don't know yet how huge mission it will be, but it will be big. The idea is that the rover picking up the samples doesn't have to do the science again that Perseverance is doing. So it can be a bit more simple rover. That task is to go and pick up the samples and then bring them back to some kind of a return rocket.
Does your institution actually have any of the has dust been returned? Has any material now been returned to Earth?
Not so far.
Right.
There's only some meteorites that we know that come from Mars, but there is no
from
Mars
or sampling. That is the plan in this collection structure.
That is the plan. Yeah, because even though Perseverance can do a lot already, it's like a moving laboratory. There's still more that could be done on Earth.
When you expect to have these samples?
Yeah, they have more than one spectrometer. They have different types of spectrometers on board.
And will this be part of this 2022 launch? The collection?
You mean the sample return?
Yeah.
Not yet. This 2022 is only a European rover. It's called Rosalind Franklin, but that is also really interesting because it has a huge drill and it's going to drill below the surface. And like I said, below the surface is really interesting because there might be frozen water and there might be life.
Maria, I have a question. Do you do public outreach and presentations in school? Does your institution do a lot of engagement with schools in Finland?
I would say that maybe not as much as we could. There is schools that know that they can come to us, and I bring students to our lab, but that is it's a small scale activity. There is also some kind of Luma science school that knows that we are one of the labs that they can visit. So we do some.
Well, you are a great spokesperson and presenter, and your excitement makes, I think, all of us really engaged in this presentation this afternoon.
Thank you.
I sincerely want to thank you. I also should tell my Cape Network people that we have a November 5th deadline for mobility ideas. We have money, so if you want to come to visit Turku, you can certainly, I would think that it would be possible, you can stop at Maria's institution on the way through Helsinki. I assume the laboratories are not open to the public.
No.
Okay, but anyway, are there any other questions from our small but dedicated group this afternoon? We have participation from Faroe Islands, we have from Latvia, Lithuania, and Switzerland. Hi, Erla. Dr. Olson.
Hi. No, you can hear me now.
Yes.
I don't have any question. I just want to thank you very much for this excellent presentation. I really enjoyed it, and I was unfortunately too late to get the beginning with us. So, but I think I caught up with the mess. What you I think I could follow what you are saying anyway, and it's very inspiring. And you know, I have this life on Mars thing, and that people are wanting to colonize Mars and establish a colony there as a So I also my consideration about Mars is that the way, as if we spoil this or Earth here, is Mars the next station, that will there be condition later on? Should we say as within? We are talking a more geological time. Also, will there be better circumstances for life on Mars later on, or has that time passed? That's maybe more what I am considering. But thank you very much for this excellent presentation.
Yes, thank you. Yeah, this question of colonizing Mars is, of course, something that is discussed a lot lately. From science perspective, there is no need to send humans. We can send these robotic explorations. And truly, it would be easier to live undersea compared to Mars if we look for a refugee for humans because we spoil our planet. Mars is very difficult to try to colonize. I see there was also a question in the chat. How do you expect rover finds and picks up the samples? Is this rover has some kind of image recognition where it recognizes automatically how it's supposed to look and pick it up? This is a good question. I have not seen this sample return rover yet, so I don't know how far the plans are, but it will know the exact location of the stash, and it will have a ton of cameras, I'm sure. So probably it could be operated similarly to Curiosity and Perseverance. So you drive somewhere and then you take pictures. Then the operators on Earth see these pictures. Okay, it is located there. Now we know where it is. Okay, there's a sample or a rock right in front of us. Let's plan an arm movement that will go and grab a sample. Then they will send a script for this arm movement to the rover. The rover does it when it gets the commands, and then it sends back to Earth again telemetry and pictures. Then the operators on Earth then again see that, haha, okay, we catch the sample on our arm, excellent. And then they program the next step, like put the samples in your pocket kind of commands. So it goes like slowly, step by step.
Everybody, thank you so much. Maria, thank you so much from our Cape network. There are going to be many people watching this YouTube video that will be up on our website in the next 24 hours. And we welcome you back anytime, maybe in person the next time that we're able to get together. Thank you once again. Thank you everybody for participating. And okay, nice comment from Sally from our friends in Klaipeda. Thank you very much, everybody. Have a nice rest of the day. And once again, Maria, many endless thanks for your presentation today.
Thank you for having me.
Just brilliant. Bye now.
Thank you. Bye.